Hello everyone. In this video, we will talk about scientific notations. So we'll begin with the definition of scientific notation. A number in scientific notation has the form n multiplied by 10 to the exponent k. So always stay in this form. Okay, so 10 to the exponent, multiply that with a number. So let's define n and k. So n is a number consists of 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that in this list, I'm missing the number 0. Okay, it has a lot to do with the number 0 here, because scientific notation in a way that you get rid of all the trailing 0 or the leading 0. And for the k, it's an integer. K has to be an integer. So you know integer is defined as a whole number with the positive or the negative sign. Okay, so k cannot be a decimal, but n can be a decimal. But the 0 in the end, we need to get rid of all the leading 0 and the trailing 0. Okay, to write a number in scientific notation, there are several steps that we have to follow. We are going to move the decimal point to the right of the first non-zero digit. The number of places that the decimal point is moved is equal to the exponent k. So it's the exact step that we have to follow here. So you indicate the decimal point, then you move the decimal point to the right of the first non-zero digit. So the direction that you move the decimal point will identify whether your k is positive or negative. Alright, so if you move to the left, then k is positive. You move to the right, k is negative. Okay, so when we ask to write the number in scientific notation, what you need to remember is you have to find the decimal point and then move it to where you find your first non-zero digit, and you have to place it on the right of the first non-zero digit. Okay, and then you drop all the trailing 0, and the place that you move will be your k. The direction will be the sign for k, which is positive or negative. So for this example, I would like to let everyone know that the decimal point is invisible because we have a whole number, and then the decimal point is always after the very last digit. Okay, so if it's a whole number, the decimal point is located at the very last digit. However, it's invisible, so we have to write that in before we can start moving it. So I'm going to move it and place it to the right of the first non-zero digit. In this case, the number 4. Okay, so if I move, I will count at the same time. So I will count at the same time when I move this. So I will write 1, 2, 3, 4, 5, 6. So the decimal point would go right after that number 4. So it will be equal to 4.35. So drop all the trailing zeros, okay? Now you're going to write it as times 10 to the exponent. Times 10 to the exponent is part of the scientific notation, and in this case I move 6 spaces, so I will write 6. Now the next step is to identify whether this k is positive or negative. I move it to the left, so it will be a positive sign. Okay, so I want to write positive 6, just to make sure to tell everyone that I indicate the sign. But it's the same thing as you write it as 10.35 times 10 to the exponent 6. It doesn't have to be a positive 6. But if it's a negative, you must write the negative sign. Okay, so writing a positive sign, you have an option of not to write it. Then it's understand that it's a positive number. Alright, so let's move on to the next one. Okay, so example number 2, the decimal point is visible. So I am going to move it and place it beside to the right of the first non-zero digit. So in this case it's 5. Okay, so I'm going to move here. Okay, so I will do 1, 2, 3. Okay, so I will write it as 5.6 times 10 to the exponent 3, but it now is a negative because I'm moving it to the right. Alright, okay, so just to make sure that everyone master the concept of writing a number in scientific notation. Okay, to write a number in scientific notation, your decimal point always stay to the right, like after the first non-zero digit. Okay, after the first non-zero digit. Okay, so this is quite useful in calculation, and also presenting certain number when it's really small or it's really big. And then sometimes you find that 10 to the exponent positive 6 or 10 to the exponent negative 3 will have their own symbol and as well. And it becomes some sort of prefix, which we will learn in the next unit. It's called engineering notation. But in this unit, we are learning about scientific notation. So scientific notation, simply just a number written in this form, okay, okay, and then times 10 to the exponent. That exponent is an integer, positive or negative, depends on the direction that you move the decimal point. So keep that in mind. So this one is completed, and also this one is completed. Okay. Now, so what about doing the reverse? I have a number in standard form, and then I have a number in scientific notation, and I have to write it back in standard form. So standard form is just the normal decimal notation that I have right here. So that means standard form or normal decimal notation, then I don't have 10 to the exponent right here. Okay, so that means you have to get rid of the 10 to the exponent k. So in the way that if you have your calculator, it's very simple. You just take 5.69, you multiply by 10 to the exponent 3. However, if we have to follow the step, then we just have to do the reverse step that we done above, right? So if you move to the what you do is you are going to move to the left and move to the right. It's the reverse process of what you have done. However, there's one way that you can remember in doing this if you don't have the calculator. Okay, so take a look at 10 to the exponent 3. This is a positive exponent. So if you get rid of this 10 to the exponent, this number right here, 5.69, has to increase. Okay, so that means you are going to move the decimal point to the right. So the exact reverse of what you have done above, right? So here you move to the left for the positive. Now get rid of the positive 10 to the exponent of the positive number, then you move to the right. So because sometimes left or right can be confusion. It can cause a confusion. But what you can keep in mind, if you get rid of the 10 to the positive exponent, this number has to increase. Okay, so that means I am going to move the decimal point to the right in this case. Okay, so I know that is 5.69. So I am moving it 3 places, right? So 1, 2, 3. So what happened here? I have to insert the 0. All right, okay. So I have to insert the a 0 as a placeholder. So let me write it like this for everyone. So I will write it as 5690 as a standard form or a normal decimal notation. Okay. So example number 4 is the you see you are going to raise this to the exponent negative 5. So that means you are going to move the decimal point to the left. Or you just remember you are going to make this number smaller by get rid of this because your exponent is a negative number. So that means you are going to move the decimal point 5 places to the left. Okay. So now I'm going to write 2, 7, and I'm going to move this. Okay, so 1, 2, 3, 4, 5. So my 0 should be right there. So therefore, I am going to put in the trailing 0. Okay, put in the trailing 0. In this case, I should have a 0.0000927. So you can check again. Okay, you can check again. So you go 1, 2, 3, 4, 5. So it will be 10 to the exponent negative 5. Alright, so you have to put 0 in as a placeholder, and I strongly recommend that you put 0 point just to be clear. So this is a standard form of this number, or the normal decimal notation for this number. And you see that it's quite inconvenient writing all of the 0. So therefore, scientific notation is quite important in representing certain number. And also we've learned about significant digits. So in this case, if you write your number in scientific notation, it's easier for you to identify the significant digits in this case. Alright, okay, so let's move on to the next example. The next one is about working with scientific notation, but involving the exponent rule. Okay, so we have gone over these formulas in previous lesson. So if you multiply the two powers with the same base, what you do is you add the two exponents and leave the base the same. So what I'm going to ask you to do in this case is I ask you to write the following number in scientific notation, but it looks like it already has the 10 to the exponent. It already has a 10 to the exponent, but this number is not in scientific notation because the decimal point is not placing beside the first non-zero digits. You see that? It's 16.7. So in scientific notation, this decimal point has to be right after the first non-zero digit, which is right after the 1. So what I do is I have to convert the 16.7 to scientific notation with a 10 to the exponent, and then I apply this rule to write the number in scientific notation. So what we do is I will take a look at this number first. So it's 16.7. What I do is I move the decimal point here. So it will be 1.67 times 10 to the exponent of 1, right? Because I am moving it to the left. So my k is a positive number. But I have to time this with 10 to the exponent 3. You see? Now I will apply the exponent rule for this. I multiply the two powers with the same base as 10. So I can write this one as 1.67 times 10 to the exponent 4 because I'm adding the two exponent. I'm taking 1 plus 3 to have 4 because I apply this rule. Alright? Okay. So let's go to example number 6. So again, this number is not in scientific notation, even though I have 10 to the exponent already here, but the decimal point in this case, I have to move it to put it right beside the number 1. So I will do this by start moving at this one, 1, 2, 3.5. So I'm going to pick the decimal point and I move 1, 2. So I will have 1.235. Okay, you have to keep the 5 because it's not a 0, so you cannot drop this 5. So still place the 5 there. And then I time this with 10 to the exponent 2. Okay, rewrite the 10 to the exponent negative 5. And I'm going to combine these two. Okay, so then my final answer will be 1.235 times 10 to the exponent of 2 plus negative 5. So that will be negative 3. Okay, so let me write it here for everyone here. So this will be 2 plus negative 5 equal to negative 3. Okay, so and here I just want to make a note that is 1 plus 3 equal to 4. Okay, so just to make sure that everyone knows where the 4 and the negative 3 coming from. Alright, so let's continue on. I have a few examples. So in this case, I have 0.0036. Okay, so I'm going to move the decimal point and place it right after the 3. So I should have 3.6. And in this case, you are moving it to the right. So you will time this by 10 to the exponent negative 3. And then rewrite the 10 to the 4 here. Combine these two. Okay, so my answer should be 3.6 times 10 to the exponent 1, positive 1. Okay, and we should indicate that, okay, to the 1, because k now is actually equal to 1. And I make the note here, negative 3 plus 4 equal to negative 1. Just to make sure everyone know that positive 1, I'm sorry, okay, thinking two things at once. So this here, you can know that is positive 1, okay. The reason I'm kind of paused is because I want to let you know that is nothing wrong with writing it like this, okay. Nothing wrong with writing it like this. Still present the number in scientific notation. In this case, the 1 is can be invisible. If you just 10, it's assuming that it's 10 raised to the exponent 1, or 10 raised to the exponent of positive 1. Alright, so if you write 3.6 times 10, it's nothing wrong with that. If you write 3.6 times 10 to the exponent positive 1, it's also correct. Okay? Very good. So now let's move on to this example. I rewrite this as, okay, and then I am going to move the decimal point 1, 2, 3, 4. So this number will become 6.9 times 10 to the exponent of negative 4. So now I write times 10 to the negative 7, and then I combine these two. So in this case, you have negative 4, okay? You add that with negative 7. So this will give you negative 11. So therefore, I am going to write my number as 6.9 times 10 to the exponent of negative 11. Okay, very good. Okay, so let's recap what we have done, because I have a few more examples here where I multiply the two scientific notation numbers. Okay, so I will have a few to go over. So in this particular page, or this particular details, or any example that I ask you to do here, I ask you to write the number in scientific notation. So it's very easy to see that, okay, I have the 10 to the exponent 3 here, so this number is in scientific notation already, but actually it's not, because scientific notation, according to the definition, is the decimal point has to position to the right of the first non-zero digit. Okay, so we have to watch for that. Okay, excuse me. So I kind of zoom it out too fast. Alright, so now, and in order for us to write this number to be to scientific notation, excuse me, I'm sorry, I just want to get a sip of tea. I can tell you that tea goes really well with math. Okay, so now 16.7 is not a number in scientific notation, so I have to move the decimal point to where it's supposed to be. And after you do that, you write it as a scientific notation, but it's given another 10 to the exponent here. So you have to combine these two in order for you to get a correct answer. Okay, so let's double check that we have done everything correct. Okay, so this number is 1.67 to the exponent 4. Okay, I hope everyone uh, uh, prints the workbook and then working on this at the same time with me. All right, okay, and then we have this as negative 11. Okay, so don't forget this formulas. You multiply the two powers with the same base, you add the two exponent. So now we are moving on to where I am going to ask you to remember this formulas or recall this formula. If you divide two powers with the same base, you subtract the exponent. Okay, and before we do that, we will have to work with the multiplying these two scientific notation. Okay, so a few steps here. All right. Okay. So first of all, I would like you to take 2.5 and multiply that with 1.6. Okay. So in doing that, I will write the step down for everyone. Then I will put this together. Okay. And I know that I'm going to combine this and make it 10 to the exponent 3 plus negative 2. Okay, and this one here will give me 2.5 times 1.6 will give me 4. So my final result will be 4 times 10 to the exponent 1. Okay, or you can just write 4 times 10. So this is all correct in this case. Okay, so I multiply, so I add the two exponent with the same base as the 10. Okay, for this one, okay, this one is a bit more complicated because we have to do some conversion at the end. Okay, I still have 8 minutes left, so I do have enough time. And sometimes I tend to rush, and when I rush in mathematics, I don't recommend that you rush while you are working on it. Okay, so now I will write 3.5. You multiply the decimal notation with the decimal notation, then you write the power with the same base side by side. Okay, so because I demonstrate all the steps for everyone, so I tend to write every single step here. So if you want to skip and then you just do it in your head, that's fine. So this will give me 10 to the exponent negative 8 plus negative 3. Okay, and when I write 3.5 times 5.4, the number is 18.9. Alright, so okay, so let's start writing it as 18.9 times 10 to the exponent. Adding this two numbers, I should have this as negative 11, right? Okay, so now I'm going to ask you to check whether or not this 18.9 is in proper scientific notation requirement. It's not. This decimal point will have to move to place beside the number 1. So now I'm going to do is I'm going to write 18.9 and I will move the decimal point to this. So that means it will be 1.89 times 10 to the exponent 1, right? Because you are moving it to the left. Now you still have this to take care of. So you have to write 10 to the negative 11 here. And in the end, you are going to have 1.89 again times 10 of these two combined. Okay, so 10 to the 1 plus the negative 11. So in this case, it should be negative 10. Alright, very good. Okay, so a few steps to convert a certain number to a scientific notation or multiply the two scientific notations number. When you multiply these two numbers, that's what we do. Or some of you probably master the calculator and you just use a calculator is fine as well. But what I do here is I want to explain to everyone how to work with this using the concept of exponent or the knowledge of exponent. Okay, so I think everything is good at this point. So let's put a check mark and check mark here as well. Okay, so now let's move on to the next example. So this one is a division. Okay, so what I will do is I will ask everyone to take 7.5 divided by 2.5, and at the same time I will write 10 to the exponent negative 5 subtract 3, because I am using these formulas. Okay, I divide two powers with the same base, I subtract the exponent. So 7.5 divided by 2.5 is just 3, and in this case you have to negative 5 subtract 3, you end up with negative 8. Okay, so this one is simple, and we got that correct. But for number 12, we may have to do some conversion, okay, at the end. So I will ask everyone to take 1.25 divided by 4. Okay, so I put 4.0 here to show you that it is a number in scientific notation. Okay, and if 4 times 10 to the exponent 3 negative 3 is also a number in scientific notation, 0.0 here later on is representing some significant digits. Okay, so now I'm going to times 10 to the 6. I have to subtract that with negative 3. Okay, so don't forget to put subtract and the negative 3 inside the bracket, because this 2 will turn into a positive here. So then I will have 0.3125, and I time that with 10 to the exponent positive 9, because this result as the positive 9. Okay, but this number that I have is not in scientific notation yet, so I need to rewrite this, and then I will show you that I have to move the decimal point here. So when I move the decimal point there, I will time this to the 10 to the exponent of negative 1. Okay, so 3.125 times 10 to the exponent of negative 1. Because you are moving the decimal point to the right, so the case is the negative number, and you move one place. Okay, so now I still have to write this over here, which is times 10 to the exponent positive 9, and then I combine these two, so it could be 10 to negative 1 plus 9. Okay, so then my final result should be 3.125 times 10 to the exponent positive 8. Oh, okay. All right. Okay, so let's see if we have any more example. No, we don't. And I have plenty of exercise for everyone to work with, and solution is actually posted as well. Okay, so we double check here that sometimes when we divide two numbers in scientific notation, we end up with a number like this, and we have to check whether or not this number is in scientific notation. Then we have to do some conversion using our knowledge of exponent. So in this question alone, you have to use two formulas. You need to use the formulas for, okay, and then you also have to use the formulas for the division as well. Okay, so I think I'm about to get to my 30 minutes, and thank you everyone. I think I end the lesson here. Thank you.